Welcome to topic 3401. Emergency Shelter Design for Eco-Resilience. Key Concepts and Frameworks EPD-Net, Filling the Gap. Ecological Planning and Design Learning Network and Adaptive Smart Training Module for Disaster Resilient and Sustainable Cities. We will see the topics of learning objectives, key concepts. What is the concept of emergency architecture? Why emergency shelter design is important. The principles of eco-resilient emergency shelter design, energy efficient, sustainable and local materials, using feedbacks on post-disaster recovery, summary and takeaways in the content of the topic in order. Learning objectives of this topic are learning the principles of eco-resilient emergency shelter design, exploring sustainable, local materials and modular design principles and understanding environmental, social, and cultural aspects of temporary housing. The subjects that we will discuss under the key concepts are as follows. Firstly, we will examine the definition, content, and reasons of emergency architecture and ask why emergency architecture is important during disasters. Secondly, we will discuss to focus on the principles of eco-resilient emergency shelter design, what topics can contribute as data to the design process, and what needs to be researched. Thirdly, we will examine why we should prioritize energy efficiency in shelters and why we should choose local and sustainable materials. And lastly, we will discuss about post-disaster recovery, using feedbacks and experiences. What is emergency architecture? Emergency architecture is the response of architecture during disasters. Emergency architecture is an organized actions and strategies employed to manage and mitigate the impact of hazardous situations of disasters. The concept of emergency architecture is minimizing the risks and managing an effective strategy in designing and construction processes by using experiences and feedback data, researching the socio-economic structure, reviewing material supply and construction capabilities, and finding cost-effective solutions. Emergency shelter design can minimize the negative physical effects of disasters and ensure the economic, social, and cultural sustainability of the disaster area. If we want daily life to be normal as quickly as possible after a disaster, shelters need to be designed according to the economic and social level of the disaster area. So, when we decided to design and build comfortable shelters for survivors, we must not to forget the budget and use low-cost materials and local workforce. When we examine the principles of eco-resilient emergency shelter design, in designing process, firstly we have to learn about past daily life of the survivors. So, we decided to make surveys with survivors and deep searching to learn about cultural and economic aspects, social life, neighborhoods, jobs and spatial preferences and request about aesthetical, physical, functional and usefulness. Secondly, we have to search about spatial requirements, such as number of rooms, daily functions in a house, etc. And local construction techniques and material choices, climatic inputs. Selected materials must be suitable for different seasons and climate conditions, depending on socio-cultural characteristics, number of family members, daily life activities and the preferences of spaces caused to make additions and modifications on shelter units. To avoid structural deformations on shelter units, we have to consider about flexible design for indoor and outdoor spaces. Foreseeing possible additional spatial requirements or using experiences and feedback information, we can pre-design alternative additional spaces for different kind of expectations by using interior and exterior wall panels and/or light membrane covers. Thirdly, we have to decide about survivor, feeling themselves insecure and away from hazards. To reduce their trauma, we should prioritize shelter designs with strong structures, durable materials and local materials. It is very important for survivors adapting to their new shelters to return to their old lives. We must help them on adapting to their new shelters and ensuring the participation of survivors, NGOs and local authority in the design processes. In designing and construction processes, we should decide to use light and portable materials, because transporting and carrying easily from different countries or production regions to the construction site is a very important and economically. And also, we should decide to use storable materials, because we need minimal space use for modules and stored easily until a disaster. We should build the infrastructures without degrading the quality of agricultural lands. Due to the concepts of eco-resilient emergency shelter settlements, We should not forget when installing the structure of the shelters we must remember to choose options that will reduce the productivity of the fields, which will be used for agriculture in the future. Infrastructure resources such as electricity and clean water have been damaged due to the disaster. It is necessary to develop alternative solutions. Integration of renewable energy could be an alternative solution in many cases. Solar energy can use for lighting and operating the electrical tools and equipment. Rainwater harvesting can use for hygiene and cleaning purposes. For sustainable construction processes, we should use multi-purpose structural elements for using in different sections of the shelter unit. The same structural elements can be used as beams and columns or panels for walls, ceiling and floor. We should also choose mountable and disassembled joint points for using shelter several times. Cold-mounted components allow for repeated disassembly, reassembly, replacement, and reuse. For construction processes, we should choose materials that are suitable for the climate and local use, consume less energy. This approach makes it possible to increase energy efficiency, reduce construction and managing costs, and build eco-friendly structures. It is expected to have materials and details that are readily available and constructed locally. This approach is important for reducing construction time, balancing the budget, and utilizing the volunteer participants effectively. Using feedbacks on post-disaster recovery is important not to do the same mistakes. Every experience gained from disaster recovery efforts should be transferred as feedback data. In disaster management, the design and construction processes consist of 4 stages. These are preparation, design, construction, and post-occupancy evaluation stages. In every disaster recovery experience, there will be feedback data at the end of each stage. It is possible to ensure a perfect disaster management by evaluating the data obtained after each stage. This table shows a cycle consisting of 4 stages. User participation in each stage can increase the feedback obtained from this experience. But the important thing is to learn from every mistake and not repeat it in the next process. When we look at the methods and frameworks, design and construction processes of emergency shelter, prefabricated construction and rapid deployment systems, integration of renewable energy, solar, rainwater harvesting, and participatory design with local communities, NGOs, and local authority are very important. There are numerous case studies. Post-disaster recovery response to settlements that are affected by disasters such as earthquakes, floods, and typhoons, or to migrations due to wars in different parts of the world. UNHCR Modular Shelter Program, Shigeru Ban's paper log houses in Japan and Turkey, Rwanda refugee camp eco-shelter designs in Philippines. Post-typhoon resilient housing prototypes are some examples of these practices. For planning and implementation links, do not forget integrating shelter planning into national disaster strategies, promoting local production and cultural adaptation, long-term transition from temporary to permanent housing, and partnerships between NGOs, governments, and academia. As a summary and takeaways, do not forget that emergency shelters are important to minimize the negative effects of disasters. In design and construction processes, we should consider about energy efficiency, low cost, local use, sustainability. In choosing building materials, we should choose prefabricated construction and rapid deployment systems, and we should use experiences as a feedback data and participatory design in post-disaster recovery.